Now we're going to talk about static versus non-static. We've been going through a lot of code examples in the console. The main method starts out as static, but then we've made a bunch of non-static members, and now I'm going to explain to you what the difference is. The title is a little bit deceptive because there's no such thing as a non-static keyword. Either you mark something as static, or it's non-static by default. So the absence of static means that whatever is defined belongs to an instance or object, which means that it's created with the new keyword. You can mark a lot of things static: classes, methods, fields, properties, operators, events, constructors. There's all sorts of things that we can mark as static. But what does static mean? It means that whatever is marked as static does not belong to an object. It belongs to the class itself. We've already seen this in action. Console.WriteLine. We've never had to create a new console. We can just use the WriteLine method. That is because it's static. Marking something as static has some interesting repercussions. Static members can't use instant members. I'm going to show you some examples of this in a moment. If we mark a class as static, then all members of that class must also be static. And if it is marked static, you can instantiate it. A static class cannot be used with the new keyword. You also cannot inherit static classes. We're going to get to that later when we talk about inheritance. And there's only ever one copy of a static. But why should we make something static? This is something that if you put 10 developers in a room, you're probably going to get 10 different answers. It's more on the artistic side of how you design your code. But basically, we can make something static when it belongs to a class, but it doesn't depend on any particular instance of that class. So ask yourself, is this operating on an instance? Or is it just something that's related to the type? A great example of this is pi. Think about it. Is pi related to any particular circle, or does it belong to all circles? So statics belong to the class. We don't have to instantiate an object to get to the static members. I already mentioned console WriteLine, console readLine, int.parse. Those are all static methods. Here, I've created a class called conversions, and it has a public static double method, miles per hour to kilometers per hour, and it takes in a miles per hour parameter, and it returns the result of the calculation. You'll notice in the code in main that I can call conversions dot miles per hour to kilometers per hour without ever using the new keyword. Statics are very handy for this kind of work, where you just want to use a method and you don't really need an instance of an object. Statics can't use instance members. So take a look at this code. Imagine we have a class called car, and I put my miles per hour to kilometers per hour static method inside that. The car has a private field called current speed. I cannot use that field inside the static method. Think about it this way. Because the static belongs to the class car and the field belongs to an object of car, we could have hundreds of cars in memory, but there's only one method because it's static. So if that method tries to use an instance member and there's thousands of them in memory, how does it know which object it's supposed to work on? It doesn't. That would be impossible. So it doesn't work that way. You're going to get an error message that says cannot access non-static field current speed in the static context. That just means in a static method. Statics and object instances. Instances can use static members. So here's a class circle. I'm going to have a static double pi that's going to return 22 divided by 7, which is close enough to pi. And I just want to make a note here. You would never write your own pi function. There is a math class that's built into .NET, and it has things like pi and trigonometry methods and things like that. But regardless, Each circle has a radius property and an area method. And if I have a circle with radius 5 and I have a different circle with radius 10, they're both going to use the value of pi to calculate their area. So it makes sense to make pi static in this case, because all circles need it, but we don't need multiple copies of pi. There's only one pi. Static members cannot be used from the instance object though. So in this code, I've created a circle object, I've set its radius to 5, and then I could write out its area. But if I try to write out c.pi and try to use pi like a property of the object, it's not going to let me do that. If I want to print pi, I have to call it directly from circle. So console.writeLine circle.pi. So what do we make static? Application settings. A lot of times we'll create settings classes that have paths to directories and files, database information, server addresses, log settings. We also use them for general calculations. I already mentioned that the math class in C# has a bunch of statics for pi, powers, square roots, trigonometry functions like sine, cosine, and tangent. Any general purpose data. Sometimes we have objects that there should only ever be one of. There is a developer pattern called the singleton pattern. When you get into more advanced programming and design patterns, singleton is one of the first ones you learn. It often uses statics because singleton means there should only be one. And lastly, any method that does general tasks like formatting. Those are perfect to make static. There's some pros and cons of using statics. Statics are great because they're very slightly more efficient. And I always warn my students when I talk about something being a performance benefit, because 90% of the applications that you're going to make when you're learning as a developer, it's not going to make any difference. We're talking nanoseconds of save time. So not a big deal. Not really a valid reason to use a static versus a non-static unless you are building a really high performance system. However, using them is less code to write than having to instantiate objects. So it's a little more terse, it's a little easier to get to. Moving general purpose methods into their own classes can keep the code cleaner. So instead of embedding pi inside the circle class, putting it into some kind of math class or calculations class can keep that code out of the circle and make it a little less distracting. Statics also have downsides. A lot of times when I go in and I work on somebody else's application, I can find that classes sort of become dumping grounds for unrelated items. So they have classes just filled with all these statics that don't have any cohesion with each other. It can make things very difficult to find when you're going through their code. Also, if we run into the need to extend our code, static classes cannot be inherited, so they're not good for extension. And then lastly, when a static reaches into instances of objects, that's usually a sign that it should not be static. It probably belongs in the instance. And that's really all there is to statics. They're a little confusing for beginners. I would say don't panic. Oftentimes if you're using a tool like ReSharper or some kind of code analysis tool, it will let you know when you've written a method that's a candidate to be a static. And you can kind of follow along with that to start with, and over time you're going to develop your own opinions about it. And as long as you're consistent, people reading your code are going to be pretty happy with what you do.